are going to build this game today, and I will start from scratch, and then we'll train our AI, and then we'll see the AI playing this game actually. So before we start, you should be knowing basic programming so that it will be easy to follow. And then you need few tools like an IDE where you can write code and run the program. And we are going to use Python for this video. So get Python installed, and I'm going to use PyCharm for this video. So get this installed, and then let's get started. So I have opened PyCharm. I will create new project, and will give the project location like where I want my project to be created. And here we'll select project in virtual environment, and then the Python installation, and then we'll hit create, and then let's open it in new window. So the project is created. I can see the virtual environment is created. The virtual environment I'm going to use here because I will be installing few libraries, and I don't want those to be installed globally, so I just want it to be used for this project. And if I hit like terminal, I should be seeing virtual environment enabled here. So if you see this v in, it means the virtual environment is enabled, so it's good to go. Then I will be installing few packages that we'll need in this video. So I will use pip install. I need Pygame and need Python. So let's install it. Okay, so the installation is completed. If I see here, I should see those packages. So I have Pygame here, and inside lib I should see need Python, Pygame, everything is installed. Now let's go and create our new Python file, the main file. Hit enter. So our main file is created. Let's start with the main method. Okay. So what we'll do here is we'll initialize our Pygame, and then we'll initialize the Pygame screen. So what Pygame does is Pygame give us like canvas where we can render objects, and basically it will give us an environment to play the game. And there are some window settings. What I will do is I will create one new file. Let's call it settings.py. I will keep all the configurable properties there. So here let's create win width. Okay, let's give it a value of 500, and win height, let's give it 700, and let's use this here. Win width and win height. Okay. So once I have given this, here's a readable packet. What I will do is I will put one input, and just will add press enter to continue, or not called continue, let's call it exit. So what it will do is it will create a blank screen where like other objects can render. Let's run it and see what it will give. So it will give this blank screen. Now before we proceed and render all other objects, let's understand the coordinate system that it will follow. So the top left, this is going to be our origin, like 0 0, and the right side will be positive x, and the downward will be positive y. So once this is ready, let's go ahead and like create other object and render it on this. Okay, so now we'll be doing two things. We'll create the base of this Flappy Bird and the background. So let's go and create one. Let's create a package. Let's call it game, and here we'll keep all our game related stuff. Let's create one new file. Let's call it base, and here we'll create a class. Let's call it base class. Okay, and let's define an draw method. So whenever it is called, it will draw the base image. And what we'll do is we'll create one floor y. So like if I comment this and run this program, so this is our positive y, and I don't want base to cover the full part, so I want, let's say, something here. So this y index I can create like from the total window height I can configure something like, let's say, 0.85, so that the rest 15% screen will go to the base. So let's give it floor of y is window height into, let's say, 0.85, and let's create the rectangle for now for the base. So we'll use pygame draw dot rectangle, and what it we like it wants one window parameter, like window where it will render the rectangle. Let's call it win for now, we'll pass this later. And then it want like the color, which color we want the base to be, and along with that it want the location where we want the rectangle to be drawn, or we can say the properties of rectangle it want. So window will pass later. Color, let's say we'll create something like soil like color. So let's say the color is going to be 222, 184 and 135. This color I have chosen like previously, which like matches the color of soil somewhat. So for the rectangle, let's say it will start from x0 and floor of y, and then the next two parameter is its like height and width. So let's say its width is going to be window width, because if you want it to cover the full window on the like x direction, and for y direction it's going to be window height minus floor of y. So it will just cover the like bottom part. Okay, now once this is done, let's call this from our main. So once display is created, let's say I create an object of base. Let's call it base. Let's call base dot draw. So it will draw the base. We'll create one more file here. Let's call it util, where we'll have all the utilities. Okay. Here also we'll define one method. Let's say draw window. So basically we'll later put all the drawing operations here. So let's say draw window. For now we'll just draw the background here. So what we are going to do is we'll do pygame dot draw dot rectangle, and again we'll pass window as a parameter, and let's say we want like white screen as background for now, so we'll keep 255, and rectangle we want to like cover everything. So let's say from it will start from 0 to 0, and it will go like window width and window height. Okay, and this win parameter, let's accept it as a parameter here. Okay, and for base also let's accept win as a parameter. Now when we go to main, so here the display that we have set, we can use it, and on this one we can actually draw our stuff. And let's draw the like background also here. Let's pass win. Let's run it and see. There is some issue here. What it's saying, the rectangle argument is invalid. Okay, so what we don't pass it here, it has to be like this. It is like extra 100 that it took. So now let's run it, and there is nothing. So the reason is, whenever we are drawing something, then the display is already set. So whatever we have drawn, it is not updating the display. To render it, we have to call display dot, let's say, update. Okay, let's run it now, and our background and this base has been rendered. Okay, so now that we have the base and the background, let's go ahead and create the bird and the pipe. So we'll go and create new file, let's say bird, define bird class here. Okay, we'll initialize it, let's say height and width. I'm going to use fixed size. So this xy I have taken as parameter, so it will define like where our bird is going to be. So let's assign it into self, and then we'll define draw method. Again, it will take window as a parameter, and then we'll use Pygame draw rectangle window, and for color let's take something like yellow to 55 and 0. And for rectangle, let's say it will start at self.x and self.y coordinate, and we'll have height and width of, let's say, 10. And then let's create an object of this bird here. So we'll have bird, let's say bird, and it want x and y, where we want to draw it. So let's say we want it at 100 on x direction and 300 on y direction. Then we'll call like bird.draw. Okay, now that we have the bird ready, let's go ahead and create pipe. Okay, here also we'll define class, let's say pipe. Okay, so what we need to draw pipe, so all we want is like where this pipe should come. So we don't want all these parameters, we just want the like x direction where this pipe should come. The y will decide dynamically, different pipe will have different height, and it will be like divided into two part, top, bottom. So those things will calculate actually. So for now let's just keep x, and then define the draw method. It will again take window parameter, and then what we are going to do is we are going to calculate the height of top pipe, like till what point we want that pipe. So what we'll do is, let's say top pipe height, and let's use some random value to decide that, so that it will have some dynamic value. So I'm going to use random for that, random dot random range, and I want it to be something like, let's say, from 50, so that it will have at least height of 50. And then like we have from top 85%. So let's say when height into 0.85, and let's keep 50, at least like 50 should be the height for the bottom, so we'll take that much length. And then let's say between the top pipe and bottom pipe we want some gap, so that much also will reduce, so that we'll have at least 50 unit for the bottom pipe. And for pipe gap, let's say we'll create one variable in settings. So for now, let's say we'll keep 150 unit. Okay, let's import it. and let's convert it to int actually, so that if we multiply it, it should remain int. Yeah. So that now we have pipe height. Let's draw the pipes. So we'll use Pygame, draw. Again we'll use rectangles for now, and it will draw on the window. And for color, let's take a greenish color. So let's take this one, and where we'll draw it. So it will be like from x direction, it will be on self dot x, and y, like it should start from 0, from the like very top. So we'll keep it at 0, and let's remove this width. Let's say we want 30 unit of width, and the height, it should have like what we have calculated. Okay, so this is our top pipe. So let's say it is top pipe. Now let's draw the bottom pipe. So bottom pipe, again it will be similar. Let's say pygame, draw rectangle, and again it will be drawn on window. We want same color here, it should start at the same position. Now let's define these parameters. Okay, so why, where it should be. So we have like this top height here, and then we want to put some like pipe gap. So let's put that thing, and the width we are going to keep like 30, and window height, actually we can calculate the height that is remaining, but for now let's give win height, because anyway it is going to down, means it will not be visible if it goes outside windows. So let's keep it like this. In the main, let's draw the pipe now. So we'll use pipe equals to pipe, and let's say I don't want it at 100. Let's create it as at, let's say 400. Let's call pipe dot draw. Let's pass the window. Anyway, it is updating already, so no need to update again. Let's run it and see. So we have the pipe, we have the bird, we have the background, we have the base. Okay, now let's add some physics to the bird, and let's see it moving. So here I'm going to introduce one new variable here. Let's say tick count. We'll soon see its uses. Let's initialize it with 0. Now we'll have the move function for the bird. Let's call it move, and whenever it moves, we'll increase the tick count, and to move it, like we'll calculate the displacement, like how much it should move. Okay, so displacement, we have a simpler formula that we will be using from science. Let's say that's called ut plus half at squared. So it's like u is the velocity that we define, and t is the time, or here we'll refer to the tick count, and half and a is nothing but the gravity. So it will simulate like the gravity is pulling the bird downwards. So we are going to use this formula. So here we need first of all the velocity. So let's define the bird velocity. Bird velocity. So the bird will be trying to move upward, so we'll take the negative value here. Let's say it takes -5, because we have considered like downward is positive, so upward is going to be negative. And here we'll use that bird velocity into self dot tick count plus 0.5. Now we need a, let's say, let's define that. Let's call it gravity, and let's define it to be 1.0. Let's multiply it with gravity into self dot tick count square. So this will give us like displacement, how much it has to move. Let's give a maximum displacement, like if the tick count has increased and it keep falling, the speed might like increase too much. So let's give a max cap. So let's say if displacement, let's say greater than 10, then we are going to use displacement as 10. And second thing is like if displacement is negative, then we don't want to move too fast, so we'll make it like displacement of, let's say, just -2. Okay, now we'll update the self dot y to, like, we'll add the displacement. So whatever direction based on move we decide, the y coordinate will of the bird will change. So the bird is not going to move forward or backward, so the x position will remain same where the bird was spawned first, but the y position keep changing, like up or down, it based on it flap or the gravity pulls it. This is pretty much for move. Let's create one method for, let's call jump. So whenever it jumps, all we will do is we'll reset the tick count, so it will become 0, so that the first time it comes, like it will calculate to be negative and it will try to move like upward. Okay, so pretty much for this bird physics. Okay, now that we have like defined the physics to it, let's see it in action. Let's go to main and let's try to make this bit playable. Okay, so now what we'll do is we'll try to make it playable. So we'll first initialize it, draw the window, and let's create one while loop. And let's say while we have running flag, it will keep running. And let's define one running flag. So let's say running is true initially. And here what we'll do is we'll try to capture the events from the Pygame. And let's say if the event is like quit, then means if we are quitting the game, we'll just make the running false. Otherwise, if the event type is key down, like if some key is pressed, that event will be captured here, and we'll try to capture the key, which key is pressed. So let's say whenever space, like a space bar is pressed, we want the bird to jump. So what we'll do is we'll make it k space. Whenever a space bar is clicked, we want our bird to jump. So before that, let's create one bird. So we'll like take this bird out from here and define it outside. Okay, so whenever we have this, we'll make the bird jump. Okay, and what else we want? So every time we come in here, we draw everything. So let's say we'll draw these here. Okay, let's remove it from here and let's run it. So the problem here is we have a flickering effect here, but if I press space, nothing happens. Okay, so let's do one more thing. So after jump, like bird will jump, but what we want is we want the bird to move when like it comes here. So we want bird dot move. Okay, now if we play the game, we don't see the bird because bird has moved and it has fallen, gravity has pulled it. So what we'll do is we'll add some tick here, like we'll add a frame so that our game runs slowly. So let's create a clock, and then inside this we'll tick our clock, let's say 10 times a second. If I run it now, you see the bird is going and the gravity is pulling it downward. Okay, now if I run it again and if I press the space bar, it will keep moving. If I press space, keep moving. If I don't press, it will fall. So the bird is pretty much reacting to the space bar and the gravity. Okay, now we'll add the physics to our pipe. So we'll go to pipe and let's define one more value here. Let's say pipe velocity. Let's give it value of 5 and we'll define one move method. Define move and let's say whenever this move method is called, pipe x position will be reduced by pipe velocity. Okay, now let's go to main and every time along with bird let's move the pipe as well. So we have the pipe here, so we'll try to move it and then draw it. So let's say pipe dot move. Now if I run the game, nothing happens. Let's see why. So the reason is nothing happens because we are creating the pipe inside the loop every time. That's why the new pipe is created and that is actually being drawn and moved. So we'll move it outside loop. Let's define it here. And now if I run it, the pipe is moving, but the problem is the position is changing. Let's see why. So if I go to pipe, you see, let's go to pipe. What is happening here is the draw is actually calculating the height every time it is called. So what we'll do instead is we'll put it into the init method so that it is just initialized once and same can be used. So we'll put it here and we'll use that. Okay, now if I run it, it should behave properly. Yeah, so bird is falling. I can like press space bar and it will go up, and otherwise it will fall, and the pipe is also moving. Okay, so now we'll basically check for the collision. Like if I run this here now, if you see, even if it crosses the pipe, nothing happens. So we'll try to add this collision detection here now. So we'll go to pipe and we'll define one method, let's say collide, and it will take, let's say, bird as a parameter. And now let's check if it has like collided. So what we'll do, if bird dot x means the position of x and plus 10 the width of bird, if it is like greater than like x ordinate of pipe, that means it has collided, and bird of x is less than self dot x plus 30. So basically what we are checking is the bird current position is within the range of pipe. Like if our pipe is this area, the bird is within that area. So if bird plus like width of bird has crossed the pipe and it has not exited, so that part will be covered from this position. And what we are going to check is, now we'll check for the x coordinate, so that if bird has like overlapping with the pipe, so we'll check for self dot y is greater than bird dot y. So what it will check is if like the top pipe has like overlapped with the bird, or self dot y plus, let's say, pipe gap, okay, is less than y, or so bird dot y plus 10. Uh, this variable, let's correct it. There is some typo here. Okay, so we'll go to the pipe and let's put it into one bracket so that we don't have conflict of calculation. And here also let's remove this and use pipe cap instead. Okay, so now if we have this condition met means like we'll return true, that means it has collided, otherwise we'll return false. Now let's go to our main and check for collision. So we'll check for, let's say, after we move the pipe, we'll draw it. Let's check for the condition, or we'll check after updating it. So if pipe dot collide bird, let's say running is false, so we'll stop the game if it collide. Okay, we have just to update it here. Let's use pipe cap. Let's run it and let's let it overlap with the pipe and see what happens. So you see, once it like overlap, it has ended. Okay, and we see an error here, like the pipe doesn't have any y like y attribute. And why it is? Because here we have that pipe height but we don't have y. Let's call it y so that it is y of like top pipe, and based on that only we'll do the calculations. So let's change it to y, this one also to y, and it should be fine. Now let's run it, and now let it collide. And yeah, now if you see, after collision it has stopped and we can exit it. Okay, so now we have the game, playable game. We'll not go and add more pipes here and make it more like complete Flappy game. Instead we'll go ahead and we'll start adding our AI. So let's close other tabs. Let's create one new package. Let's call it AI, and let's create one file here. Let's call it neat trainer. So basically we are going to use this neural evolution with augmented topology, and this is basically a neural evolution algorithm using which like multiple populations and multiple species will be created, and the best genomes out of those will be taken and the process will happen so that it will evolve and make better decisions and can play this game. And to run this game, like we'll need some configurations related to neat that we need to feed it. So what I will do is I will not create it from scratch, I will copy it from my previous reference that I have. So let me copy it, and anyway I will share these files. Let me paste it here, and let's see, it had some configuration like how much fitness it should have to consider it the fittest, what should be the population size. So it's like how many population will be created in each species, and we have other configurations like it is related to the neural network, like how many inputs we are going to provide and how many output we are like expecting those things. So I will not go in much detail for this now. Let's go and define our run neat method. Let's say it will take config file as a parameter, and based on that it will do the configuration for the neat AI model. Okay, Here what we'll do is we'll create some global variable, let's say highest score, where we'll store the score, like whatever is the score that is like across generations, and let's initialize it with 0. So let's say highest score is 0, and then we'll actually create the neat configuration. So let's say config, and that is going to be neat config, and we'll pass the parameters. So first one is going to be let's say this neat default genome, then we will have default reproduction, default replica, sorry, default species set, and default destination, and then we'll pass the our config file here. Let's format it a bit. Okay, so based on this we'll get a neat configuration which our like AI can use to make the decisions, and all these values are actually defined in this config file that basically will refer to this one here. Okay, now that we have this configuration, let's create our population. Let's say population equals to need.population, and we'll pass this config. So it will basically give, based on like how much population we have defined, it will create those many like birds basically. And then we'll add some reporter to get the stats. Let's add one more pop dot add reporter. Let's add the std out reporter, so that it will get the stats and print on the standard output, that is our terminal. Okay, now let's define a global variable to capture the generations, and let's initialize it with 0. Okay, now we'll add the logic to select our best genome. So based on multiple runs, it will select the best genome that can play the game very well. And what we want, like what we'll pass here is, we'll pass one lambda. Let's say it will be called genome, and then we'll pass one fitness function. Like we'll have some logic based on like how AI is playing game. We'll put some fitness value to it, so that it can make based on those fitness value, it can decide like which species and which bird is playing better, and do the crossovers and then select the best genome for us. So we'll pass one config, and let's say we'll have one eval genome method. We'll create this later. So this will be actually the method where we'll have the fitness calculation, and then we'll pass the max generation that we want, for like how many generation this AI should try. Let's create this value in here. Let's say max generation, I want it to try for maximum of 50 generation. Okay, so we'll import it here. Now we'll define this method. Okay, for now let's pass it, and once we have the best model or best genome, we'll save it. So what we'll do is, with open edge, let's say best genome file, and we'll use basically one more library. It's called pickle, and we'll dump our best genome in this file. Okay, what this is fine, so it will basically add it here. We'll create best genome, let's say best genome dot pkl file, and it will be in write mode, in binary write mode, so it will write to this location. Okay, now let's go to this eval genome and we'll write this logic here. Okay, so what we'll do is we'll first of all reference the global variables that we have created. So let's say global highest score and global generation. And what we'll do is we'll increase the generation value with 1. So every time it comes here, we'll increase the generation value. So the first time it comes, we'll start with the generation 1. So let's make it this way. Now we'll create a few arrays, let's say nets. So here we'll have the neural network for each bird, and then let's say GE, so genomes of the bird and the birds. Now this method is going to take two parameters, let's say genomes and the configuration. Okay, let's pass these two values from here. So we have genomes, let's use genomes, and config, let's call it genomes. So basically neat will create the genomes and pass it over to this method. So what we'll do is we'll loop through each genome and then we'll calculate its fitness and all. So let's say we have genome in genomes. Okay, let's create the net for this genome and append it to the nets. So nets dot append, let's create a bird. Let's say bird is equals to bird, and what we'll do here is we'll define the position where the bird should uh, should be spawned. Okay, so let's create the bird. Let's say bird, and like its initial position is, let's say, 230 on X and 300 on Y. So this bird, again we'll append this bird into our birds array, and then initialize the, let's say, fitness with 0 and add this genome to our G array, that is to store the genomes. So now for each genome that we have received, means let's say our population size was 100, so need will create 100 genome and pass it here, and will assign the fitness of 0 as initial fitness and append it into our genome array that we have created here. So now for each bird we'll have a net, we'll have a genome, where we'll have the fitness. Okay, now what we'll do is basically whatever we have done here we'll be removing it. So basically this part will be move to this. So here only we'll create the uh, initialize our Pygame window. Let's import it. Okay, Python is not imported, let's manually import it. Okay, so now window is created. Let's create a clock. Okay, let's say for each run, actually this method will be called for each run. If first generation is all bird died in the first generation, the next generation will be created, then again this method will be called. So we'll initialize the score to 0 for each generation level, and let's say run equals to, this is a flag that says like if it is still running or not. Now what we'll do is uh, we'll create a loop basically to check if run is true, means the game is running, and the length of bird, let's say, is greater than 0, means we still have some birds alive. So what we'll do is first of all we'll tick our clock, and this time let's keep it at 30 fps. This is like frame per second, so in each second it will refresh 30 times. And then we'll capture the event. So if event is quit, let's make it done as false and quit the pygame. Otherwise, let's continue. Now so we are going to create the pipes. So till now we have seen like we just created one pipe, but now we can have like multiple pipe. If one pipe is gone, next pipe should be spawned. So what we'll do is, let's say we'll initially have one pipe only, but again it will add the another pipe. So this pipe index is basically to will check like from the pipe array that we have against to which one the bird collision and all should be checked. So let's initialize it with 0. And what we'll do is, if length of pipes, so pipes is not defined here, let's create the pipes. But here we'll create one pipe, let's say pipes, and let's define it like pipe. And let's say it is spawned outside our window. So the window length that we are using is how much, let's see. So the window length is 500. Let's spawn our pipe at somewhere around 500 only. So let's use pipe of 500. Okay, now here what we'll check is if our like length of pipe is like greater than 1. So like we have more than one pipe. If we have just one pipe, means that index will remain 0 only, like we'll check against that first pipe. But if it is like more than one pipe, and let's use first bird, anyway the exposition of all the bird is going to be same, but so we will just pick one bird and its exposition will compare against pipe. So let's say pipe of 0 means the first pipe that we have, x plus pipes of 0 dot pipe top. Okay, anyway it's not important. Let's use instead of this, let's use pipe of x, and let's check its width. So the pipe width we are using is 30. So if it is like if bird has crossed the pipe, then we'll use pipe index as 1. It's the next pipe that is on the position 1. Now what we'll do is, whatever bird we have, so we'll loop through all the bird and we'll like move it. So all the bird will move every time this loop runs, means the clock is tick, the bird will move, means in 1 second it will move like 30 times. And then what we'll do is, for that bird the fitness value will increase to some value, let's say 0.1. So this is like we are giving survival fitness, means if this bird has alive for these many tick, so it is getting one fitness, so that AI can decide like the more time we survive, the more fitness we'll have. Okay, now it's time to decide like if bird should flap or it should free fall. So for that what we'll do is, we'll like make the decision. So we'll, for each net, like for each bird we have the nets. So nets at I will activate that net. And like as we have defined in the configuration file, like we'll have 3 input and 1 output node for this. So what we'll use it, we'll give bird's y position as one of the input, and we'll use pipes at uh, let's use pipes at pipe index dot y as the second input, and pipes at pipe index dot y plus pipe pipe pipe. So basically we'll use the difference between like bird position and the pipe position. So let's say bird dot y minus, and also bird dot y minus, let's use its absolute value, so it's don't give us like negative values. Let's format it. So basically based on these three values, it will decide, it will make some decision. And if that decision value, let's say if output, and let's use it 0, since it gives array of output, but we have defined like it will have only one output. So let's see, if it is greater than 0.5, then we'll make our bird to move. Sorry, not move, we'll make it to jump. And if it is not greater than 0.5, means it has decided to let it free fall. Okay. And now what we'll do is we'll define the conditions to add new pipe and remove the pipe. Those are passed. So let's say add pipe, initialize it with false, and the file like pipes for removal, let's initialize it with empty array. Now we'll loop through all the pipe and then all the bird. Okay, now we'll check for collision. If pipe has collided with this bird, what we'll do is we'll give a penalty. So if the bird collide with the pipe, its fitness will reduce by 1, so that is the penalty it will have. And then this bird will be removed from our array because it has already collided, so it should die actually. And we'll remove the corresponding net and the genome. Okay, and then we'll continue for like other bird. Okay, next thing is if the x location of like the x location of pipe, if it has crossed bird, means it has gone less than bird's x position, then we'll make add pipe as true. And then like in each loop, what we have to do is we have to move the pipe, and we have to move all the pipes that we have. So we'll do pipe dot move. Okay, now we'll be checking if pipe has like moved to the extreme left and it has crossed the window. So what we'll do is if pipe dot x plus, sorry, plus let's say 30, that is the width of the pipe. If it is less than 0, then we'll like add it to rem so that it can be removed later. Okay. So now once this is done, we'll check like if we need to add the pipe. If yes, means the bird has crossed one pipe, so it should get a score. So what we'll do is we'll increase the score by let's say 1. So each pipe the bird crosses, the score will be increased by 1. And we'll just reset the high score also. So if the score is greater than highest score, let's reset it highest score to score. And we'll give a fitness value to each bird that has that is still alive. So what we'll do is for genomes in G that we have left, we'll add a fitness of let's say 5, so that whenever it score, it get a more reward, so it will try to score more value. Okay, so now once score is done, we'll add a new pipe. So pipes dot append, and we'll append a new pipe. pipe at, let's say, in 500 at the extreme right. Okay, once this is done, let's check if we have to like remove a pipe. So we'll check for R in rem. So whatever pipes are to be removed from the pipes, let's remove that. Okay, now we have checked the collision, we have moved the pipes, added the pipes. Now the thing that is remaining is if the bird crosses the bottom of the screen or the top of the screen, means it flew away or it crossed the ground, so we should remove that bird. So we'll do that part. So again we'll loop through all the birds and let's check if bird.y plus height of bird, that is 10, is greater than window height, or bird.y plus 10 is less than 0. Then again we'll like pop all the birds. In this case, birds.pop I, remove its nets.pipe and remove its genome, and then finally we are going to draw the window. So we'll draw window. Okay, so till now we were like drawing the background here, but now we'll have to draw everything using this method. So we'll like accept window on which it has to draw the birds, the pipes, everything, like the base, the score, whatever is the highest score, and the generation value. Okay, now let's pass all these values from this. So we have the window, we have the birds, we have the pipe, base. Let's create like a new base. Okay, score, high score, generation, everything we have here. Now let's go and draw it. So we first draw the background. Let's loop through the pipes and draw it. So for pipe in pipes, pipe dot draw. Okay, and if you see the pipe, it takes win as parameter, so let's pass the win. Similar way, let's draw the bird dot draw. Finally, let's draw the base. Okay, so now the basic stuff is drawn. Let's create like this text for score, highest score, generation, so that it can be displayed on the screen. So what we'll do first is, let's say score renderer, and we'll use like we need to define the fonts if we want to use like the text to be drawn on the screen. So what we'll do is pygame.init, so that pygame is initialized before these fonts are defined. Let's call it stat font, and let's use none. We don't use to use any name, no need for that. And let's keep the size as 30. Okay, now what we'll use is using this one, we'll create these values. So let's keep the color as black, and same way let's create for the other values. Let's say score we have, let's say highest score, we'll use the value of this. Let's call it highest score. Let's pass the value. then we have generation, and then let's use how many birds are alive. Let's say length of birds. Okay, now that we have these things, we'll draw it. So when we are drawing a rectangle, we can directly use Pygame draw, but since we have these surfaces now, like if you see render, it will give us the surface. So to draw the surfaces, we'll use win dot blit function. So we have like what we want to draw and then where we want to draw. So if you want to draw on like 0 0, we can use this. So what I will do is I will use, let's say, highest score on the left side. So let's call it 10. We'll add some padding, 10 10, and the score I will draw on the right side. So what we'll use is, let's say, win width minus score render dot get width. So whatever width it has minus 10, so it will add some padding from the right side, and from the y we want 10. Okay, same way let's do for generation and bird alive. So let's say generation render, let's draw it on the left side only. So let's say 10, let's add some padding, let's keep it 30. We'll remove this, we'll use this one only. So let's say birds alive and let's draw it at 50. And once we have drawn all these things, let's update the display. Now that this is done, let's run this from our main file. So now we don't need all these things. Let's remove it. Okay, so now what we need is, we need to load this configuration file so that we can pass it and it can be used to train our AI model. So what I will do is, first of all, use os dot path dot directory name, just to refer the local directory. Okay, now let's define the config file path. So os path json, sorry, join, and we'll use local directory, and along with that we'll give our file name. Copy, let's pass it here. Okay, and then let's run the trainer. So let's say run it and let's pass the config file. Now if I run it, let's see what happens. And we have few errors. I will try to resolve it. Okay, so what it says is, it missing one required positional argument config. Okay, so the problem is the way these genomes are passed. So let's say it is genome id and then genome, so it is passed like this inside this one. So we, if we refer like alone, it gives a issue. So we can dereference genome id, though we don't need it. Now let's run. Still we have issue here. Okay, so what it says now, it need parameter config, that is unfilled. So we have the config, let's fill it and let's see now. So it is running, but this is the problem. Now we have some issue with the pipes being loaded randomly. So let's see There are some issues I think with the like indentation that we have used. That's why like pipes are getting just rendered. And if we see where we are using this add pipe parameter, so add pipe is false, we are making it true here, and here we are checking if add pipe is true. So once the first pipe is crossed, it is always going to be true. So somewhere we have to make it false, or we need to check like if the pipe is already passed. So let's do one thing. Let's create one like pipe passed value in the pipe, so that we can track if this pipe is passed, so that like we don't add it every time. So let's say self dot passed, initially it will be false, and then let's see. So here we are saying add pipe true. Here let's say if not pipe dot passed, and so if pipe is not already passed, then only we'll do this one, and we'll make dot pass to true, means now it has passed. So it will be anyway, if it is passed means it will be removed later. So the next pipe that will come will have pipe passed as false. Now let's run it. Okay, so now the uh, AI is playing, but the thing is this scores and this stats are not pretty much visible. So we'll close, we'll try to use different color. Go to util and see what color we are using for rendering these things. It is 25, let's make it black. Let's use 0 0 0. Okay, so now we see the birds alive is 1, means it is just creating one bird, and the generation is also not updating. Okay. Okay, so there are some indentation issue here. Let's fix that. Like this while loop, it should not run for each genome, but it should be like common. Once we initialize the genomes and the birds, it should be actually running. So let's like remove one indentation and try it. So now we have 100 birds. Generation 1 scores highest score, everything is updating, and let's see how it plays. So as we see, like we have multiple generation, and as we move ahead in the generation, the birds are playing better and they are evolving. So actually we have defined like highest threshold fitness as 10,000, and to reach it, like it might take too much time. So what we'll do is we'll stop this one, and we'll do like if it has reached like let's say score of 20, we'll say like it has been trained, and we'll like put some good fitness value, so that the game will pause there. So what we'll do is like here, if the score is let's say score is greater than 20, then we'll stop our game. Let's say we'll make run as false, and that will be our best model. Let's try to run it. So it's been actually difficult for it to play. Like if it goes down, the velocity is not enough to reach up. So we'll tweak it with. Let's stop this game and we'll do some tweaking. Like the randomization will reduce a bit. Let's make it 100, and here also let's make a gap of, let's say, 100. Now let's play. Let's tweak it a bit more to what we'll do is we'll reduce the randomization, let's say 150, and another thing we'll do is we'll reduce these velocities, let's say, a bit. Now let's see. Okay, now another thing we have seen is once it reaches the score, it actually restarted, but it did not stop it, and did not select the best model. So let's add that condition. So what we'll do is we go here, and if like the score is greater than this, we'll give a really big uh, fitness. So we'll add the fitness of, let's say, 10,000, so that it reaches the maximum score. Okay, and another thing we see here is, here we should be adding the fitness, giving the reward, not subtracting it. Let's see now. So it seems like it is playing much better now. So what we'll do is we'll make it a bit difficult. So we'll go to pipe, let's make it 100, here also 100, and let's play now. Okay, so now it has reached like 21, and it has stopped. Let's close the game, and if you see here, best genome.pkl file is saved. This will have the best genome that we have. Now we'll create another file. Let's call it watcher, and basically here we'll write like logic to make AI play the game. So actually the logic will be mostly similar, like how the decisions will be made. It's just that we'll have single bird this time. So let's define a method first. Run with AI, let's say. Let's do one thing. It will also take config as a parameter. So we'll have similar configuration here. and or we'll call it config file, and then we'll create the config similar to what we have in this trainer. So let's copy this, let's put it here. Okay, so now we have config, let's import it. Then we'll load our file, the model that we have saved. So let's say copy, use this here, and this time we'll load it into read mode. Let's say best genome file. Okay, and then we'll load the best genome using pickle, and then let's make it play. So let's say play, and we'll pass the best genome. Okay, let's create this play method. Let's create it better. Def play, and it will take genome and config. So here let's pass the config as well. So here also we'll have a similar thing that we did in the trainer, but only thing is here we'll have just one instances. So let's say bird, let's create the initial pipe. So the pipes will be multiple in this case as well, so we'll have the pipe array. Now let's create the window, and the clock. Okay, let's again define the run. While run, what we'll do is we'll tick the clock. Let's say again 30 fps. Let's capture the quit event, and we'll have the similar logic that we had earlier for the pipe, like calculating the pipe index. So let's pull it from here. Okay, and this time we just have single bird, and then we'll have this deciding factor, and net also will have just one because we have just one bird. Okay, bird will jump, and in each tick the bird will move. Okay, now let's add the add pipe logic. We'll use actually take this. Okay, so here we don't have these things defined, so let's define it. Let's say score is 0, and here we don't need to check actually all the birds because we have just one bird. Okay, fitness and all will have just one, and actually no need to pop it. If it collide means we'll just make that run false. Let's format it. This time we don't need fitness, we don't need highest score, we don't need this fitness. Let's skip this part. So if we have like scored 20 means we'll think like it has played well. So we have pretty much everything now, and we'll go with the draw. So once all these are done, so same way we have called the draw method here, we'll call it. So let's go to the watcher. Once all these calculations are done, let's call the draw method. Okay, so here we have just one bird, so we'll pass it as an array. Let's say pipes we have multiple, that's fine. Base anyway we have one. Let's say highest score will pass 0, generation also 0. We don't need this. Let's add one more field, let's say from watcher, so it will decide like if it is from watcher then don't need to render these things like highest score, generation, those things. So here we'll add one more flag from watcher, and let's say initialize it with false. Now what we'll do here is, let's move this up. What we'll do here is, if not from watcher, then only we'll render these things. Okay, so now have everything set up. Let's go to main, and what we'll do here is, see here we are running only the trainer, so we'll create some menu. Let's say print, enter your choice. Okay, print 1 to train, 2 to eval, and let's say input. Let's move this here, enter your choice. Let's call it select menu, select from below options. Okay, now here we'll see if choice is 1, then we'll run the training. If choice is 2, we'll run this watcher. So we have this method here, run with AI. So let's call this one. So from this we'll call this run with AI, and here also we'll pass the config path. Now let's run it and try. Let's give 2. Let's see if it work 2. So it is working fine, but we see the score is not running. Actually it is running and then resetting it. Let's see what is going wrong. So we'll go to run with AI, and if you see here we are increasing a score here and defining it here. So the thing is, it is defined in loop, means every time it is getting reset. So let's move it outside, let's put it here. Now let's try. So now the score is increasing. Yeah, it's working fine. Let's see if our AI can score 20. So I think did not have the velocity or the capacity to reach this point. Let's try again. Okay, seems like the height is the random height is causing issue. It is not able to make it, though it is trying to keep flying. So what we'll do is we'll tweak the height a bit. So we'll open pipe. Let's make it 150, 150, and then we'll try. So it will reduce the randomness. So it has crossed 18, 19, and 20. So it is able to score beyond 20. So it has trained and it is playing well. So with this, the main logical part is completed. So now we'll actually replace all the rectangles with the images, so it gives the realistic view, and it will give like the bird is flying and the real pipes like that. So we'll try to add that. So we'll load the sprites and since the images and use that instead of the rectangles now. So I have copied these images here. I will share it and with you, and let's start with the background. So here we have the rectangle. So instead of that, we'll use the this background image. So let's do image load. So it will load the image first. Let's give the path, let's say steps like this, and then convert it so we get a surface out of it. Let's call it background image, and then we'll transform it. So let's say bc equals to pygame transform scale, and we'll transform it like scale it to the windows size. And then we'll now since we have surface, so we'll use win.lit and load it at 0 0, like it will start from the origin and cover the full area like windows width and height. Okay, let's remove it now and let's run it. Let's run with watcher only. So let's select 2, enter, and let's see. So we have the nice background now. Okay, let's close it, and we'll go next and we'll do the similar thing for our base image. So let's close this, let's go to base, and here we'll do the similar thing. So let's call it base image, and here we'll put base.png. Okay, and here we'll have let's say base image, and it will have the height and width of this one. So it will scale to this much, and the position will give is this 0 and floor y. So here it should load. So let's say at this point, let's remove one extra bracket, and let's call it base and pass it here. Okay, we'll run it again, and let's see how it looks now. So now we have the background also and the base also. Now let's go and we'll replace this pipe with the image of pipe. So let's go to pipe. What we'll do here is we'll like create two values. Let's say pipe top image and pipe bottom image. So we'll do similar way like pipe pygame dot image load, and we have the pipe images here. Let's copy that and give it here. assets slash pytalk.png. Okay, and then convert it. Okay, and similar way we'll do pipe bottom. And let's copy this one and pass it here. Okay, let's assign it to a variable in the class, and when drawing it, let's refer it. So now instead of drawing this, we'll draw this top and bottom images. So what we'll do here is we'll get or we can do, like, instead of the loading every time, like, we can create this surface here itself. So let's say pygame dot transform dot scale. Let's do this thing also here only. So it will scale by this much. Let's say width is 30 and height will be self dot y. So it should scale to this much. Let's assign this to self dot top pipe. Okay, let's not assign it to this for now, and similar way we'll do for similar thing we'll do for the bottom pipe as well. And here want to scale this thing. Okay, and here we want to scale the bottom image. Okay, and the bottom image we want to scale by this much. Okay, and then while drawing it, let's use window blit and self.top pipe, and let's use this, and y will be 0. Now we can remove this one. Same way, here we'll use win.blit, and here we'll do the that for bottom pipe. So self dot let's name it btm pipe. Self dot bottom pipe, and the location will be this one, self dot x, and this. Okay, let's remove this and let's see. Okay, we have some problem here. It's saying this file is not found. Okay, the name of file is not correct. So let's use this. Now let's try. This one. Let's stop and try again. Okay, some error happened. Let's move this part to here, and let's try. I think till now maybe the pygame is not initialized while creating pipe. That's why it is not working properly. Here we'll not use self. Instead, let's make these things. And actually we can't convert also if pygame is not initialized. So we'll keep like this, and here we'll try to convert it. Self dot and dot convert dot let's make it self dot bottom image dot convert. Let's make it like this. Now let's give it a try. So yeah, Now if you see, the pipe has also got the image and it looks much better. Now only thing left is the bird. So let's go to that part. Okay, so if you see here, for bird we have three images, one for downward flap, one for middle flap, and one for up flap. So that is like what position its wings are. So what we'll do is we'll create images and array, and we'll load all the three image here. Okay, and let's do assets, and first of all load the, let's say, down flap. Okay, and then let's load the middle flap, and then the up flap. Now what we'll do is, uh, first of all in the draw, and before that let's initialize one variable, let's say image index, initialize it with 0. And what we'll do here is we'll load image at image index, and that only will draw here. So here we can do pygame dot transform dot scale, and we want to scale the images, let's say self dot images at image index, self dot img index, convert it, and then give the size. Let's say here we have 1010. Let's go ahead with 1010. It should be a double. Okay, now that we have this, let's render it. Win dot blit cell. Okay, not this time I want like this. Let's say bird, and let's draw the bird, and it should be at self of x and y. Okay, now if I run this, I should see the first bird. So bird is there, it's very tiny. Let's increase its height a bit, and its wings are not flapping, so let's make that happen. So first of all let's update, like every time it make a jump, let's update its image index. So let's say self dot image index is equals to self dot image index plus 1 modulus of 3. So every time it will increase by 1, and there's do a reminder division, like whatever is left after dividing from 3. So first it will take whatever at 1, like 0, then 1 2, and then reset it to 0. Okay, now if I run it, I should see it flapping the bird, like wings. But there is some issue here. It's saying it cannot convert index. Okay, image index is going beyond. So we have 3 images, and when we are, okay, not plus, but it should be reassigned. So let's see, still some issue, index out of range. Okay, let's put it into bracket. Well, now it is flapping the wings, but it is very tiny. Let's increase its size. So instead of 1010, let's make it 2020. Now we can see its wings are flapping. Whenever it is trying to go upward, means make it jump, wings are flapping. So there are a couple of things to change, like since we are changing the size everywhere where we want to refer its like height and width, we should update it. So but I will keep it like this for now, or I can change it to 1010 so that it will be consistent. What you can do is you can keep it into a settings.py that we had earlier and use from there, so you don't have to change everywhere. Okay, so now we have everything in place. It can play very well. Okay, and similar things would happen when we like run the training part. So it's similar thing happening. We have multiple birds, all will keep flapping whenever it try to jump. Okay, so we have this ready. Now the next part is we can add some like sound effect whenever the bird is flapping or it hit the pipe, or whenever we like it score some point. So those things we can do. Okay, so this sound part I will add only in watcher, because if we add in uh, like trainer, we'll have like hundreds of bird flapping, it will create a noise. So let's not add it there, let's only add it inside the watcher. So the first thing we need to do is we should initialize a Pygame mixer that is used to create the sounds. So let's initialize that, and we'll add some assets. So let's add a directory, let's call it sounds, and I have it in another project. Let's copy that. So I will be using just three sounds for now. Whenever it flaps the wing, whenever it hit a pipe, or whenever score some point. Okay, now let's load all these three files. It will be similar to how we loaded the images. So pygame dot mixer dot sound, and let's load from assets slash sound, and let's say it is hit. Let's take this name here, and I don't want to play here but just load it as a global like class level variable. Let's call it hit sound. Same way, let's create a wing sound and point sound. Okay, let's copy this. This is for point, this is for wing. So we have this thing here. Let's see where we can add it. So the wing sound we can add like whenever it is flapping the wing, means whenever like we are making the bird like jump. So we have here bird dot jump. So here what we'll do is we'll make pygame dot mixer dot sound dot play, and here we'll play the, let's say, wing sound. Okay, let's copy this. Then whenever it scores, we'll play the point sound. So let's say when we are increasing the score, let's play the point sound. Okay, and whenever it hit the pipe, that time we'll play the hit sound. So whenever it collide, let's play hit sound. Now let's play in the watcher mode and see. Uh, okay, what we'll do to get the hit sound, let's make it crash. So we have trained it on different set of data. Let's try to change the configuration. So let's say we have the pipe, and if we change the pipe gap, let's say the pipe gap instead of 150, if I make it, let's say 50, very small gap, what will happen? It has crashed here. Okay, so with that we have the full game ready. So there are a couple of things that is not taken care, like that I leave to you to check it and update it. Like when we added the images, we did not update the collision logic. So now this collide logic might not be uh, accurate, because now we have the images. So we need to actually get the mask from the sprites and use that to check the collisions. Okay, but I am not going to cover that here. So our main motto is achieved. So we have the game, and we have like AI that is been trained and it is able to play. So I will keep that to 150 and save more time. Okay, so thank you for watching. I will upload this code to Git and will share the link with you in the description. If you like this video, and if you have learned something today, please like this video. Put your comments if you have any doubt, or you are not able to play the game, you are getting some errors, and I will try to help you. And subscribe the channel and share it with others. Thank you.